Okay, now in the homework, you will have a couple where you need to evaluate, um, what is your epsilon, what is your delta. Okay, remember the delta is the error tolerance on the x value, and the epsilon is the error tolerance on the y value. Basically, your delta is how much your x deviates away, and the epsilon is how much your y deviates away, how much your output deviates away from the limit. Okay, so that's basically what we're looking at here. Your delta is your difference in the x. Your epsilon is your difference in the actual, what your output is to your actual limit. Okay? So let's take a look at this. Let's jump to this. So this is a proof, so we've got to be a little bit more formal about it. That's why I'm pulling out my notes, because I got to have exact wording here. I want to prove that the limit as x approaches 3 of 4x minus 5 is actually 7. How do we know that it's 7? Well, we could directly substitute, but we're also told that. So we're given this statement that the limit as x approaches 3 of 4x minus 7, 4x minus 5 is 7. Prove it. Okay, I like to think about these proofs as kind of like two parts. I have to figure out what delta to use. I have to figure out what delta to use, and it's got to be in terms of epsilon. So I like to think about it in two parts. There's the prep, and then the actual formal proof. I like to think about it as the prep and the proof. Okay? Because I've got to figure out what delta to use. Here's what I mean by that. Okay, so we know if we have a 0 greater than or equal to, or sorry, less than the difference away to delta, right? This is saying the difference from where I'm going to 3 and the x values that I'm choosing, 3.1, 3.001, 3.001, the difference away has to be between 0 and delta. It's got to stay positive because it's absolute value, but it's got to be between 0 and delta. And I'm going to keep decreasing and decreasing the size of delta to try to get it closer and closer and closer to the actual limit. Okay, so if we know that's true, then the absolute value of 4x minus 5, and I almost like to put this in parentheses, minus 7 has to be less than epsilon. What is that? That is the output to the limit. I want to get closer and closer and closer. I want to decrease the size of this thing, right? I want the difference to get to 0 eventually. I want the difference to be, I want to minimize the difference here. I want to make that smaller and smaller and smaller and smaller and smaller by way of making this smaller and smaller and smaller and smaller and smaller. So let's kind of evaluate this. Well, isn't that 4x minus 12? I don't really need those parentheses. I was just doing it for emphasis where I take my f of x and subtract it away from my actual limit. So that's like 4x minus 12. Now, can't I pull out the 4? And since it's positive, can't I pull it all the way out? Because it's an absolute value, I can pull a positive number out of an absolute value. So I can pull it all the way out, and now what I can use, if I divide by 4 over to the other side, y'all follow me there? Okay, well, if you follow me there, then take a look at this, and take a look at this. So what delta do you think I'm going to use? Epsilon over 4. The delta that I'm going to use is going to be epsilon over 4. That's the delta that I'm going to pick. You always pick a delta that has epsilon in it, because we want to make delta in terms of epsilon. Because basically what's going to happen is the proof is saying we're going to continually make delta smaller, which forces epsilon to be smaller. Okay, so what I want to choose is epsilon over 4. Now that we have this, we are done with our prep portion. Now we go to our proof. This is what we're going to use out of our prep. Come on. So here's our formal proof. So we say, given that epsilon is greater than 0, so we want to preface this that I want to have a positive epsilon, because I'm just creating a variable, basically. And variables can be whatever we want them, but we've got to restrict it because epsilon's got to say positive. We want to say, okay, epsilon's going to be positive. We're going to create another variable delta such that delta is epsilon over 4. This is kind of like our premise. This is kind of like our setup to a proof. This is kind of like, if you were in geometry, this is my diagram. Right? This is my, these two triangles are congruent. Prove something else. So this is my premise. Given that epsilon is greater than 0, we're going to choose delta that is epsilon over 4. Well, we know that if this is true, the difference away is less than delta. Okay? The difference away from x minus 3 to the difference of x to 3 has to be less than delta. Then we know that the output is kind of like working backwards within our proof, within our prep portion. Then this is where we start our work. 4x minus 5 minus 7 is equivalent to 4x minus 12 which is equivalent to 4, I'll keep it on the inside, then I'll pull it out, x minus 3, which is equivalent to this. Right? All of those things chain together very nicely here. But we also know that the absolute value of x minus 3 is less than delta, right? And what if I multiply each side of that by 4? Because that was part of our premise, right? I can say that because that was part of our if statement. So what if I multiply both sides by 4? Now, do you see how this is going to chain together? Look. Oh, I'm sorry. Sorry, that 4 shouldn't be there on the inside. I only needed to multiply to the outside. Sorry. So 4 absolute value x minus 3 has to be less than 4 delta. All I did was multiply both sides by 4. Now, do you see how this is going to chain together? This right here matches this right here. So we can say that 4x, the absolute value 4x minus 5 minus 7, just taking the first part of this, has to be less than 4 delta. Look, I just chained that all together. I took this part, chained it all the way to here. But what do we know delta to be? We chose delta to be what? Epsilon over 4. So that concludes that. Okay? And that's the end of our proof. That's the final statement. You want to get to the end by saying the difference between the function and the output of the limit is always going to stay less than epsilon. Basically, our if statement was, if the difference between x and 3 is less than delta, then the difference between the function and the output is always going to stay less than epsilon. Difference between the function and the limit is always going to stay less than epsilon. This is like your hypothesis. This is your conclusion. This is your ending statement. Okay? Weird, right? Okay, we'll do one more proof, hopefully after the quiz tomorrow. Who came up with this? Who came up with calculus? Leibniz. Leibniz. That guy. Blame him.